We lost you back there, cowboy. All right, here we go. Back at it. Okay. So we're evaluating these values here, and I'm just going to give them to you. Or we can just test them real fast. Notice how we are evaluating the original to find the maximum y value and the minimum y value. Okay, so f of -1 is -5. F of 0 is just going to be 0. F of 1 is going to be 2 minus 3, which is -1. And f of 2, who knows, is a scary decimal. Okay, so our absolute minimum is going to be at, or when x is -1. And then our absolute maximum is going to be at 0. Look at the graph. That's not that graph. Look at the graph. Does that make sense? Yeah, there's like a little minimum happening over here at 1, and then there's a little maximum happening right here at 0. Okay? I'm going to show you how to confirm these on something called a number line in a couple of seconds, okay? So right now we're just talking about intervals of increase and intervals of decrease. So this first derivative can tell us where the locations of the possible maxes and mins are, and it can also tell us where the graph is increasing or decreasing. So if the sign of the first derivative is positive, the graph must be increasing because the slopes of the tangent lines that you draw along that curve have to be positive because the graph is going up. Whereas if the graph is decreasing, the slopes of the tangent lines will be negative because as you draw the tangent lines along that curve, they're going to have a negative slope. And then right at maxes or mins, we've got a slope of 0, okay? So intervals of increase on this graph right over here are going to happen from -10 to -8. And then we have another interval of increase from 1 to 6. Whereas intervals of decrease will be happening from -8 to -1. There's just one. All right. So when the first derivative is positive, that means the first derivative is positive. The function is increasing. When the first derivative is negative, the function is decreasing. So we're going to let c be a critical number on a continuous interval. So now we're dropping that whole closed interval nonsense, and now we're just talking about regular old functions. And now we're just finding the maxes and the mins. And you can drop that language of like absolute max, absolute min, local min, because that only happens on a closed interval. So now we're just talking about maxes, mins on a regular old function. This is what you will be using 99% of the time, okay? So it says, let c be a critical number on a continuous interval. If the first derivative changes from positive to negative at c, f of c is the relative max. That means if the graph changes from increasing to decreasing, that makes perfect sense. There's a max there, right? Whereas if f prime of x changes from negative to positive, so the original graph is decreasing to increasing, then we've got a minimum there. What does that look like on, or with calculus? Here we go. Let's do some, figure out what these graphs look like. And this is all really cool because guess what you can do now? Sketch really weird stuff with this information after today and tomorrow. So this guy says, find intervals of increase or decrease in all the relative extrema. Remember, extrema is the overarching category for maxes and mins. For f of x is equal to 2x cubed plus 3x squared minus 12x. So let's find the derivative first. Let's set it equal to 0. I don't need to set it equal to where, or find where it's undefined because he's a polynomial. He doesn't have a denominator. There's no problemo there. So I'm just going to do 6 times x squared plus x minus 2 equals 0. I pulled out a 6 because each term had a 6 and I have to factor it, so. So once you have these two x values, These are the locations of the critical points. Remember, critical points could be maxes, mins, or neither. And the only way you can find out is by doing this next step, which is writing a number line. So you take these critical points and you put them on the number line. Get in the habit of labeling this as your F prime number line. Why? Because it reminds you of what you need to evaluate back into to check the sign. And tomorrow you're going to learn about F double prime number line. So if you're not labeling your lines, what do you think you're going to do? Confuse yourself, mess up, all that good stuff. So let's take these and put them on the number line. And these happened when the first derivative was equal to 0, so I'm going to put a little 0 up top. If these happened when the first derivative was undefined, I would put a little u up top. Is this all coming back to you from like quadratic inequalities and all that sign checking we had to do, right? Okay. So now I'm going to pick my test values. I'm going to do -4 here. I'm going to do 0 here. I'm going to do 2 here. And yeah, go ahead. Let's find these values here. So remember, you are evaluating these in the first derivative, right? You could also, actually, this is in factored form. It's way easier to just do it by hand than typing it in, right? I have a -4. I plug it into the factored form of the first derivative right here. If I plug in a -4, I have a negative times a negative. So what is this guy? Positive, okay? And then I'm going to do it for 0. Oh, and I just have positive times a negative. And then I'm going to do it for 2, and that's going to be positive times a positive. Okay? So the sign of the first derivative goes from positive to negative to positive. That means on the original curve, we have an interval of increase, followed by an interval of decrease, followed by an interval of increase. When on that original graph on f of x, we go from increasing to decreasing, we have a max. When we go on the original curve from decreasing to increasing, we have a min. So intervals of increase on the original graph are where the first derivative is positive. So we have an interval of increase from -infinity to -2, and then we have another one from 1 to infinity. We have an interval of decrease where the sign of the first derivative is negative. And that's happening between -2 and 1. The maximum coordinate is -2, and then I'm just going to write this here to remind you of like how we find the maximum point. You have to plug that -2 back into the original, because the maximum is a point on the original graph, right? So you've been testing it in the first derivative. Don't forget now, if you're just getting the maximum value, you have to plug it back into the original, okay? So let's type that guy in and see what we get. People at home, Dylan Wilson is the only person who is typing it into his calculator. Bless you, Dylan Wilson. Everyone else is waiting for the trained monkey to perform. And perform, she is not doing. She is sleeping. Hold on. Wait. Am I up in the exponent still? Oh, fail. All right, what do we get? 20. So the max is -220. And then the min, I got to plug that one in now too. So what is the min? The min is happening when we have a 1. Oh, I could just do that in my head. So I'd have 2 plus 3 minus 12. So I got 5 minus 12, so I got -7. So the min is happening at 1, -7. So let's think about this guy, right? I've got a graph. I have a min at -220, or sorry, a max at -220. I have a min at 1, -7. What is this guy's end behavior? He's, so we got positive, odd, right? What's this guy's end behavior? He's terminating in what, 2 quadrants? 1 and 3, right? So couldn't we kind of like, if we found out what the zeros are and all that good jazz, couldn't we like sketch this thing now? With just our brains? All right, cool. So we have find intervals of increase or decrease and all relative extrema for this guy. Ooh, I see a little root up there. What might happen with this little root? Little root makes a little what? Like a little seagull, right? Let's graph it. Let's see what it looks like. You didn't in fact say seagull? No. They're like, no one else was thinking that. What are you talking about? Whoa! What's this guy? The people at home, Damien is doing this with his arms right now. It's so weird. Okay, so what do you have to do? You have to find the derivative, and then let's talk in a couple of minutes, okay? Find the derivative. You what?
This graph just looks like it absolutely refuses to be negative.
Hates it. So you guys are going to want to rewrite this one because otherwise it's very hard to see what is in the numerator and what is in the denominator. Okay. So once you get your derivative, right, you're going to set it equal to 0 and you're going to have to figure out where it's undefined because now we have a denominator. Uh-oh. So if you set the denominator equal to 0, right, you divide both sides by 3, cube both sides, you're going to get x equals plus or minus 2. Is everyone okay with that one? Mm-hmm. Okay, that was a little fast. And then the top, we have x equals 0. We did those fast. Everyone's fine, though? Okay. So these are the locations of our critical points along our f prime number line. So let's set up our f prime number line. We're going to put these bad boys on here. And then label it. The 2 and the negative 2 came from where the first derivative was undefined, and then the 0 came from where the first derivative was equal to 0, right? So you're going to pick test values in between each spot and figure out what the sign is. But I'm trying to, do you guys want to cheat? Or, raise your hand if you know what's going on. All right, never mind. We'll just do it the long way. Okay. Literally, no one raised their hand. People at home, no one raised their hand. Perfect. Okay, so we'll just test this along our number line and see how we're doing. Okay, so if we typed in a -4, let's go ahead and set up our little, we're going to store a -4. And then we're going to test that in our first derivative. That was demoralizing, okay. All right, what is the interval here? Negative. Let's pick something in between -2 and 0, -1. Oh. Hi. Pick something between 0 and 2. Negative. Pick something above 2. Okay. So let's go along this number line and classify what's happening at each critical point. So at -2, the original graph is going from decreasing to increasing. So -2 is a what? A min. The original graph at 0 is changing from increasing to decreasing. So 0 is a yup. At +2, the original graph is going from decreasing to increasing. So 2 is a what? Min. Hey, does that make sense? Yeah. Okay, what I was thinking of, like, oh, we could just cheat to save time, right? Is like, what are the slopes of the tangent line from -infinity to -2? Negative. What are the slopes of the tangent lines from -2 to 0? What are the slopes of the tangent lines from 0 to 2? Negative, right? If you're drawing them, they're like going down. Do you know what I mean by like envisioning the slopes of the tangent lines? Like if I sketched them, like it's the slope of that line, slope of that line. Like you're going down, so they're decreasing or they're negative. And then from two above, the slopes are positive. So that's how you could cheat if it's available to you. Okay, so intervals of increase. This guy is increasing from -2 to 0, and then again from 2 to infinity. He's decreasing from negative infinity to 2, sorry, -2. And then he's decreasing from 0 to 2. So why am I not saying what I'm writing? And then the max is occurring at 0. So to get the point on the graph, we have to plug it back into the original, right? So we would have the cube root of -4 squared. Sounds like a calculator question. Okay, so I got 0. So I got -4. Okay, something gross. Something gross. And then the min, does that make sense? Look on your graph. Yeah, right? It could be that, sure. And then the mins, we can see they're happening at -2 and 2. If I put a -2 in, if I square it, it's going to be a 0 in there. So we know that both of these are going to be -2, 0, and 2, 0. Okay. All right. Let's try one where we got a rational function, okay? So, in all the, pretty much. So in all the cases that I've showed you so far, we had a spot where the first derivative was undefined, and it ended up being a point on the graph. It was a cusp or a corner, so it ended up being a max or a min. In this case here, right, we have a rational function, but now we have a vertical asymptote, and I know that because it's over x squared, so x can't be 0. So I'm going to show you what it looks like when we have an asymptote, okay? So we went over maxes, mins, cusps, corners. Now we're going to go over asymptotes, okay? So I'm going to find the derivative of this thing. Just for time, can I just give you the derivative? Is anyone opposed to that? I just want you to, I know we know how to calculate derivatives. I just want you to like see how we apply them. This is the first derivative. Hooray. So let's find where this guy is equal to 0, and then let's find where this guy is undefined. Well, undefined is going to come from setting the denominator equal to 0, so I know that x cannot equal 0. Where the first derivative is equal to 0 is going to come from setting the numerator equal to 0. So if I do that, I have x equals -6. So let's figure out what this number line is going to look like, right? This is my f prime number line. I have a 0 and I have a -6. So 0 came from this guy being undefined. And then -6 came from this guy being a 0. Okay, so what I'm going to want to do is I'm going to test the sign of the first derivative on either side of this guy, okay? So -7, -1, and 1. All right, so -7, +7 minus 6 is going to give me a +1, and he's cubed, so he's negative, so he's negative. And then -1, so it's going to be a negative over a negative, so positive. And then -1 minus 6, negative, positive, negative. All right, so I have negative, positive, negative. So this is definitely a point on the graph. We are changing on the original from decreasing to increasing. So -6 is a what, max or a min? Min. And then this guy, this is what is funky about this one, right? If I plugged a 0 into the original equation, could I generate the y coordinate of this guy? That's how you know in your head whether it's a cusp or an asymptote. If you plugged in the 0, you don't get anything. Whereas up here, if you plugged in the -2 or the 2, you would get a value. You would get a 0 coming out, okay? So in this case, we know that this guy is going to be an asymptote. And let's take a look at the graph and see if we can, oh no, first we have to do intervals of increase and decrease. So it's increasing from -6 to 0. It's decreasing from negative infinity to -6. And then again from 0 to infinity. The max is